Hi, how are you doing? This is AWS By Doing. I'm Madhu Vasudevan from the AWS By Doing team. Welcome to this educational video series, AWS By Doing, wherein you can learn AWS Cloud Computing by following along with an AWS Certified Solutions Architect. We acknowledge and thank the official AWS documentation material which we have used to produce this educational video. Although we will try to keep all resources consumed eligible for the free tier, ensuring that you are not charged or minimizing your charges is your responsibility. To minimize charges, remember to delete all created chargeable resources after each session. This time, we will walk you through a hands-on lab on create 2 security groups, one for web server, 2 for the EFS mount target, create an EFS file system, launch an EC2 instance, install Apache web server on the EC2 instance, mount the EFS file system on the EC2 instance, serve a web page stored on the EFS file system, and finally delete all created resources. The estimated cost for doing this hands-on is no charge, as EFS and EC2 instance are free tier eligible. The prerequisite AWS skill level is that of beginner with general understanding of EFS and EC2 concepts. To set up a free tier eligible AWS account and a user with sufficient permissions, check out our video on Create Admin User. To begin, fire up a browser, preferably Google Chrome, and head to aws.amazon.com. Sign in to the AWS Management Console as a user with administrator credentials. In this walkthrough, we will set up an Apache web server and serve Amazon EFS files. For this lab, from the region drop-down on the top right corner, select the region closest to you for best performance. We will first create a security group for the web server. To create a security group using the console, open the Amazon VPC console, in the navigation pane, choose Security Groups. Choose Create Security Group. Enter a name for the security group, for example, My Security Group, and then provide a description. From VPC, select the ID of your VPC. Select the default VPC. Add 2 inbound rules to allow SSH access on port 22 and HTTP access on port 80. Click on Add Rule. Select SSH for type. You could choose either your IP. For the purpose of this demo, maybe even anywhere. Add next rule. Allow HTTP. For this demo, from anywhere. Keep the default outbound rule that allows all traffic to leave. Add a name tag. And click on Create Security Group. Next, we need to create another security group for the EFS mount target. Follow the same procedure, that is, open the Amazon VPC console. In the navigation pane, choose Security Groups. Choose Create Security Group. Enter a name for the security group. Provide a description. Enter a name. And description and select the VPC. Choose the default VPC. This time, add inbound rule to allow NFS access on port 2049 from the web server security group. Keep the default outbound rule that allows all traffic to leave. You could add a name tag. And click on Create Security Group. Thus, you have created both the security groups required for this hands-on. Next, we will configure the file system settings. Sign in to the AWS Management Console and open the Amazon EFS console. Choose Create File System to open the Create File System dialog box. Choose Customize to create a customized file system instead of creating a file system using the service recommended settings. The file system settings page appears. For general settings, enter the following. Optionally, enter a name for the file system. For automatic backups, they are turned on by default. You can turn off automatic backups by clearing the checkbox. AWS Backup offers a fast and easy way for customers to restore an individual file or directory from the backup of an Amazon EFS file system. With AWS Backup, customers can quickly restore an individual file from a centralized console without having to restore entire file systems, reducing the recovery time from days to hours. Choose a lifecycle management policy. If you don't want lifecycle management enabled, choose None. Amazon EFS file systems have two storage classes available: infrequent access. The infrequent access storage class is a lower cost storage class that is designed for storing long-lived, infrequently accessed files cost effectively. And then there is the standard storage class, which is used to store frequently accessed files. Amazon EFS Lifecycle Management automatically manages cost-effective file storage for your file systems. When enabled, Lifecycle Management migrates files that have not been accessed for a set period of time to the infrequent access storage class. You define that period of time by using a lifecycle policy. Choose a performance mode, either the default general purpose mode or max I/O. The two performance modes have no additional costs. So your Amazon EFS file system is billed and metered the same regardless of your performance mode. An Amazon EFS file system's performance mode can't be changed after the file system has been created. The general purpose performance mode is recommended for the majority of your Amazon EFS file systems. General purpose is ideal for latency sensitive use cases like web server environments, content management systems, home directories, and general file serving. If you don't choose a performance mode when you create your file system, Amazon EFS selects the general purpose mode for you by default. The max I/O performance mode can scale to higher levels of aggregate throughput and operations per second. This scaling is done with a trade-off of slightly higher latencies for file metadata operations. Highly parallelized applications and workloads such as big data analysis, media processing, and genomics analysis can benefit from this mode. We'll go with the general purpose default mode. For throughput mode, either the default bursting mode or provisioned mode may be chosen. If you choose provisioned, the provisioned throughput MIBS field appears. Enter the amount of throughput to provision for the file system. After you enter the throughput, the console displays an estimate of the monthly cost next to the field. There are two throughput modes to choose from for your file system: bursting throughput and provisioned throughput. With bursting throughput mode, throughput on Amazon EFS scales as the size of your file system in the standard storage class grows. With provisioned throughput mode, you can instantly provision the throughput of your file system in MIB per second, independent of the amount of data stored. You can decrease your file system throughput in provisioned throughput mode as long as it's been more than 24 hours since the last decrease. Additionally, you can change between provisioned throughput mode and the default bursting throughput mode as long as it's been more than 24 hours since the last throughput mode change. We'll go with the default bursting throughput mode for this hands-on. For encryption, encryption of data at rest is enabled by default. It uses your AWS Key Management Service, that is the AWS KMS, EFS service key to choose a different KMS key to use for encryption, expand, customize encryption settings, and choose a key from the list, if you have any, or enter a KMS key ID or Amazon resource name ARN for the KMS key you want to use. If you need to create a new key, choose Create an AWS KMS key to launch the AWS KMS console and create a new key. You can turn off encryption of data at rest by clearing the checkbox. Optionally, you can add a tag, key value pair to your file system. Click on Next to continue to the network access step in the configuration process. In step 2, you configure the file system's network settings, including the VPC and mount targets. Choose the Virtual Private Cloud VPC where you want EC2 instances to connect to your file system. Go with the default VPC. For mount targets, you can create one or more mount targets for your file system. For each mount target, set the following properties. For availability zone, by default, a mount target is configured in each availability zone in an AWS region. If you don't want a mount target in a particular availability zone, choose Remove to delete the mount target for that zone. Create a mount target in every availability zone that you plan to access your file system from. There is no cost to do so. For subnet ID, choose from the available subnets in an availability zone. The default subnet is pre-selected. For IP address, by default, Amazon EFS chooses the IP address automatically from the available addresses in the subnet. Or you can enter a specific IP address that's in the subnet. Although mount target have a single IP address, they are redundant, highly available network resources. For security groups, you can specify one or more security groups for the mount target. Choose the EFS security group that you previously created. Delete the default. Choose the EFS security group that you previously created. Choose Add Mount Target to create a mount target for an availability zone that doesn't have one. If a mount target is configured for each availability zone like we have, this choice of Add Mount Target is not available. Choose Next to continue. The file system policy page is displayed. Optionally, You can create a file system policy for your file system. An EFS file system policy is an IAM resource policy that you use to control NFS client access to the file system. In policy options, you can choose any combination of the available pre-configured policies. Prevent root access by default, or enforce read-only access by default, or enforce in-transit encryption for all clients, or maybe two of them, or all three. Use the policy editor to customize a pre-configured policy or to create your own policy. When you choose one of the pre-configured policies, the JSON policy definition appears in the policy editor. You can edit the JSON to create a policy of your choice. To undo your changes, click on Clear. The pre-configured policies become available once again in the policy options. Choose Next to continue. The Review and Create page appears. Review each of the file system configuration groups. You can make changes to each group at this time by choosing Edit. Choose Create at the very bottom to create your file system and return to the File Systems page. A banner across the top shows that the new file system is being created. A link to the How to access the new file system details page appears in the banner when the file system becomes available. The File Systems page displays the file system and its configuration details. Click on the Network tab to view the mount target details. You have successfully created your EFS or Elastic File System. Next, we'll create a key pair and launch an EC2 instance. To create your key pair, open the Amazon EC2 console. In the navigation pane, under Network and Security, choose Key Pairs. Choose Create Key Pair. For name, enter a descriptive name for the key pair. Amazon EC2 associates the public key with the name that you specify as the key name. A key name can include up to 255 ASCII characters. It cannot include leading or trailing spaces. Since key pairs are region specific, for file format, choose the format in which to save the private key. To save the private key in a format that can be used with OpenSSH, choose PEM. To save the private key in a format that can be used with PuTTY, choose PPK. We'll go with PEM. Tags are optional, but you could add a new tag. Click on Create Key Pair. The private key file is automatically downloaded by your browser. The base file name is the name you specified as the name of your key pair, and the file name extension is determined by the file format you chose. Save the private key file in a safe place. This is the only chance for you to save the private key file. Having created the key pair, to launch the EC2 instance and mount our EFS file system, open the Amazon EC2 console. Choose Launch Instance. In step 1, choose an Amazon machine image. Find an Amazon Linux AMI at the top of the list and choose Select. In step 2, choose an instance type. Let's go with the default free tier eligible T2.micro. Click on Next, Configure Instance Details. In step 3, Configure Instance Details, provide the following information. For network, choose the entry for the same VPC that you noted when you created your EFS file system. In our case, the default VPC for the Ohio region, or whichever region you chose. For subnet, choose a default subnet in any availability zone. For file systems, make sure that the file system that you created is selected. Under Advanced Details, confirm that the user data to mount the file system when the EC2 is launched is present. This user data was automatically generated, and it includes the commands needed to mount the specified file system. Next, choose Add Storage. Let's go with the default. So choose Add Tags. You could name your instance. Click on Next Configure Security Group. In step 6, Configure Security Group, select an existing security group and choose the web server security group that you previously created. Click on Review and Launch. Choose Launch. Select the checkbox for the key pair that you created and then choose Launch Instances. Your instances are launching and you could view those instances, or in our case, the instance. Next, we need to connect to our instance and install the Apache web server. Select your instance and then click on Connect. And you have various options of connecting. In my case, I'll go with the Windows PowerShell. So copy the command to your clipboard and bring up the Windows PowerShell. In the terminal window, use the SSH command that we copied to the clipboard buffer to connect to the instance. You specify the path and the file name of the private key, .pem in our case, the username for your instance, which is EC2-user, and the public DNS name for your instance. Navigate to the folder holding the private key. Paste the command. When you see a response like the following, are you sure you want to continue connecting? Say yes. And you are connected. On your EC2 instance, install the Apache web server and configure it as shown with the commands. Please find all commands and code snippets in the video description. So to install and start the Apache web server on Amazon Linux EC2 instance, first update your OS. This might take a while. After a few minutes, continue. When you see the update complete message, install the Apache web server. Next, start the web server. Check the status. It's active and running. And make sure it comes up after reboot. So we can browse to the public IP address of your EC2 instance to confirm successful installation of the Apache web server. Back to the browser, click on Close and open a new browser tab. From the EC2 console, copy either the public IP or the DNS name, doesn't matter. In the new browser tab, key that in, and you have installed the Apache web server on your EC2 instance. Congratulations. Next, we need to create a mount point. First, note that the document root in the /etc/httpd/conf/httpd.conf file points to /var/www/html as the document root. For that, these are the commands, and we'll run them one by one. We don't want to edit this file, so that's fine. It's unwritable. We just want to check. Page down a few times until you see document root /var/www/html, and we are good. So Control X to exit out of that configuration file. Next, you will mount your Amazon EFS file system on a subdirectory under the document root. So create a subdirectory EFS-mount-point under var www/html. Mount your Amazon EFS file system. You need to update the mount command using the EFS mount helper utility by providing your file system ID. So let's retrieve our file system ID from the EFS console. Copy it. And replace. we have mounted the EFS in this particular location. Next, we will create a sample HTML file. And this is how we'll do that. Let's go into our mount directory. And make a directory. Ensure EC2 user has appropriate rights. To create a sample file in that directory, let's go into that directory and let's create our HTML file, hello.html. The ls command to check what's in the directory, and there it is, hello.html. Let's see what is in there. Cat HTML to see our sample HTML file. And now for the ultimate test. Open a browser window and enter the URL to access the file. It is the public DNS name of the EC2 instance followed by the file name. So let's go to the EC2 console, or rather open a new tab. And here we need to substitute the public DNS name of our EC2 instance. So we go to the EC2 console, click on instances, select our instance, the web server, copy the DNS name. You could go with the public IP2, but let's just go with the DNS name, copy to the buffer and substitute it and hit enter. Congratulations! Now you're serving web pages stored on an Amazon EFS file system. Cleanup time. To clean up resources and protect your AWS account, connect to your Amazon EC2 instance, which we already have, and run the command to unmount the Amazon EFS file system. If you also made this mistake, go to the home directory and rerun the command. And you have successfully unmounted the EFS file system. Next, we need to delete our file system. So let's exit out of our session, close the PowerShell window, go to our EFS console, click on File Systems, choose the Amazon EFS file system that you want to delete from the list of file systems. You could just click delete here, or you could go into the file system details page and click delete from there. In this dialog box, type the file system ID for the Amazon EFS file system that you want to delete. You could just copy it out of there and click confirm. And your EFS file system is being deleted. Once the file system is deleted, you need to delete your EC2 instance. So go on to the EC2 console, click on Instances, select your web server instance, click on Actions, under Instance State, click on Terminate. In the Terminate Instances dialog box, click on Yes, Terminate to terminate the instance that you created for this hands-on session. Wait for the instance state to show terminated. Click on Refresh to see that your EC2 instance has been terminated. Although security groups don't cost anything, we don't want unnecessary or unused resources hanging around. So let's clean up the security groups. In the navigation pane, choose Security Groups. Delete the EFS security group first, since the EFS security group has a reference to the My Web Server security group. So select the My EFS security group. Under the Actions drop-down, select Delete Security Group. Confirm, click on Delete. Next, select My Web Server security group. Under Actions, click on Delete Security Group and confirm the delete. And you have successfully deleted all created resources. Thanks for watching. Please give a thumbs up to this video to encourage us. Share this video with your friends and colleagues. Also, subscribe to this channel AWS By Doing, and we will update you regularly with our latest and greatest offerings. Write in a comment of what you liked and how we can improve. Happy cloud computing, and we will see you again in the next episode from the AWS By Doing team.